So today we're going to continue solving trig equations, but today's trig equations are going to require that we do some factoring to solve them, okay? So solving trig equations, but today we need to do some factoring. And for this problem, we're going to go ahead and find all solutions. Okay, so we're solving for x, and the problem is 2 sine squared minus 3 sine x plus 1 equals 0. So some students have a hard time thinking about factoring when it's written like this. So off to the side, if you want to write 2x squared minus 3x plus 1 equals 0, that is technically what we're doing. Okay, we're just doing sine x instead of regular x like this. Okay, now for you to receive credit on your assignment, you can do this off to the side. But every step you do with this, you have to write over here with a sign. Okay? And the reason I say that is because it is not uncommon for students to solve this equation and leave this as the answer. And this is not the answer, okay? This is just helping us think through the factoring process, okay? So when the problem is written like this, what type of factoring is that? It's a slide divide problem. How do you know? Got the 2 in the front, okay? So we're going to slide 2 times 1 is 2. So we're choosing something that multiplies to 2 but adds to negative 3. And what numbers would do that? Negative 2 and negative 1. And so what do we put in our parentheses? X minus 2 and x minus 1. Okay, so over here I'm going to show my work in terms of sign. I'm going to say sine x minus 2, sine x minus 1. Okay, if I continue the process of slide divide bottoms up, what do I have to do next? Divide by 2. So the number I slid is what I need to divide by. So I'm going to go over here and I'm going to show that same work over here. Okay? And then what happens with this 2 over 2? It makes 1. So this is just x minus 1. What about this 1 over 2? It's 1/2, right? But what do? We bottoms up, right? Okay, so we do 2x minus 1. Okay, so that means we have sine x minus 1 and 2 sine x minus 1. Okay, over here, what would we say x equals? X equals 1. And for the other one, we would say x equals 1/2. Okay, so that means over here we're going to say sine x equals 1, sine x equals 1/2. Okay, at this point I can scribble all this out because I'm done with that part. It helped me think through the problem, but it is not the answer. Okay, now how do I continue doing these ones? I get out my unit circle. So if I recognize that these are on the unit circle, that is my preferred answer. Okay, so I'm going to get out my unit circle. I'm going to look for on my unit circle where I have a y-coordinate of positive 1 and where I have a y-coordinate of 1/2. So my y-coordinate of positive 1 is up here, right? So for the first factor, I only have one answer. That answer is pi over 2. There's one of my first answers. And then over here, I'm going to have 2 answers. And what are they? Pi over 6 and 5 pi over 6. Okay, well, let's go ahead and try another one. So this one we're going to do 6 cos squared x plus cos x equals 1. So when you look at a trig problem that needs to be factored, it kind of looks like it needs to be factored when you look at it. Like you'll see a cos squared, you'll see a cos, you'll see that it has like the 3 pieces or the 2 pieces. It will kind of make sense that it like looks like that. Are they allowed to equal 1? No, so what should we do first? Subtract the 1, make it equal 0. Okay, so 6 cos squared x plus cos x minus 1 equals 0. So if I want to think about this as a factoring problem that's maybe a little bit easier, and I forgot to tell you what type of solution we want. We're going to look for a solution. Oh, dang. You guys, we didn't even catch it. I said we were supposed to write all solutions. So these are not right. How do we fix these? Okay. So plus 2 pi k. Okay. How do we fix these two? Plus 2 pi k. And then we would have 5 pi 6 plus 2 pi k. Sorry, that was my bad. And so the reason we had to do that is because I'd said that we want all solutions. Okay, for this one, we're going to find solutions on 0, 2 pi. So not all solutions this time, just the solutions on 0, 2 pi. Okay, so we can think about the quadratic that we're factoring off to the side. So we can think 6x squared plus x minus 1 equals 0. And how do I factor this? Slide divide again, right? So we're choosing two numbers that multiply to -6 and add to 1, and the two numbers are 3 and -2. Okay. So what goes in my parentheses? X plus 3, x minus 2, and then over here I'm going to say cos x plus 3, cos x minus 2, okay? And then what do I do? Divide by 6, so the number I slid was a 6. And this is kind of an interesting problem because both of these fractions reduce. So 3 over 6 becomes what? 1/2. So it's kind of like we have x plus 1/2, right? And then what does the other fraction do? -1/3, yeah, x minus 1/3. Okay, so we divided by 6 and divided by 6, and that gave us cos x plus 1 over 2 and cos x minus 1 over 3. And then what is our last step? Well, second to last step, I guess. Bottoms up, okay. So we're going to say 2x plus 1, 3x minus 1. So that gives us 2 cos x plus 1, 3 cos x minus 1. Okay, and then over here, what are the solutions? -1/2 and positive 1/3. So over here I'm going to say cos x equals negative 1/2, cos x equals positive 1/3. And now that I've done all my factoring, I'm going to scribble this out because this is technically not part of the problem. Okay, so what do we do? For this one, we look at the unit circle, definitely. And what do we get? Okay, so x equals 2 pi thirds and 4 pi thirds, and this time, since the instructions want us to look at just 0 to 2 pi, we don't have to worry about adding anything else, so that part's done. Can we find this one on the unit circle? No, so we get our calculators out and make sure that we're in radians. And then what do I type? Cos inverse of 1/3. So there's my first answer. Okay, and what do I do with that decimal? Store it. I'm going to store that as x. And then how do I find my second answer? So 2 pi minus x. All right, do you guys want to look for all solutions on this one, or do we want to look from 0 to 2 pi? All. Okay, so this one we're going to do 3 tan squared x plus 8 tan x plus 5. And on this one, we're going to look for all solutions. Do you guys want to keep doing the work on the side of the page that we scribble out, or do you want to just do this one with tan? Just do it the way it is? Yeah? Okay. So what type of factoring problem is this? Slide divide, okay? So we're going to say 3 multiplied by 5 is 15. So we're looking for two numbers that multiply to 15 but add to 8. 5 and 3. So in our parentheses, what should we be writing? Tan x plus 5 and tan x plus 3, okay? And then what is the next step of slide divide? Divide by 3, that's the number we slid, so divide by 3. So in the first parenthesis, the fraction cannot be simplified. So what do we do with that one? Bottoms up, so that's 3 tan x plus 5. In the second parenthesis, we have 3 over 3, which is 1. So we got tan x plus 1. Okay. So we have two solutions. -1, -5 divided by 3. Okay, so this one we can look up on the unit circle, right? So where on the unit circle do you see a y value divided by an x value that simplifies to be -1? 3 pi fourths and 7 pi fourths. Now with tan, we just write one of those answers when we do all solutions. We just write one of those and say plus pi k. So do you guys want to use 3 pi fourths or 7 pi fourths? 7, okay. So we'll say x equals 7 pi fourths plus pi k. You don't have to do both of them, just one. Okay? And then over here, what should we do? Calculator. We're going to type tan inverse negative 5 divided by 3. Doesn't matter that we got a negative decimal. The instructions said all solutions. So does it matter if it's negative? It does not matter. It would only matter if we had one of the problems that said from 0 to 2 pi. So it doesn't matter. We don't have to find the second answer because, again, with tangent, both of them are good for you to write the all solutions from. So what do I need to tack on the end of this? Plus pi k. And then that one is done as well. Okay. We're going to do one more. Well, I lied. We're going to do two more. Okay. This one is 2 sine x times cos x equals sine x. And we're going to find the solutions on 0 to 2 pi. Okay, so to make this one maybe a little bit more recognizable, this is kind of like if you have two different variables in a problem. So it's kind of like they said 2xy equals x. That's kind of like what you're factoring. So whenever we factor something, do we want it to equal something on the other side? No, we always want it to equal 0, right? So the first thing we're going to do is minus that sine x over, okay? So I have 2 sine x cos x minus sine x equals 0. And then if we think about this right here, that's definitely not a slide divide problem. It's definitely not one of the problems where we draw the x. It's only got 2 terms. So what type of factoring could we do with this? What's the type of factoring you're always supposed to check for? GCF. Do you guys see how there's a GCF in that? What is it? X, right? So you'd take out the GCF of x, and what would you have left over? Take the x out of the first piece, and what do you have? 2y. And then x divided by x is 1, so it would be 2y minus 1. So we're going to do the same thing over here, but on this one, the GCF is sine of x. So we're going to take out a sine of x, and then our leftovers would be 2 cos x minus 1. So anytime you're doing a factoring problem and you don't feel like you know what to do with it, a little trick is to kind of write it off like this on the side because your brain is more used to seeing them look like that. Okay? So I'm going to scribble this out because we don't really need it anymore. What we do with this is we take each factor and we make them equal 0, right? So for the first one, we're going to say sine x equals 0. For the second one, we already know how to handle that one, right? Cos x equals 1/2, positive 1/2. Okay, so now we're getting out our unit circle. We're looking for this one to find a y-coordinate of 0. Where does a y-coordinate of 0 happen? So over here and over here, right? This is the easy one. We know that we write pi down. For this one, I have to decide if I should write 0 or 2 pi. So based off this, which one am I supposed to write? Wait, which one's included? 2 pi. 0 is a parenthesis that's not included. 2 pi is a bracket that is included. So from this spot, the only answer I'm allowed to write is 2 pi. Okay? So for this one, I'm going to say x equals pi and 2 pi. And then for the second one, I'm looking for an x value of positive 1/2. And what do I see? Pi thirds and 5 pi thirds. Okay. X equals pi thirds, x equals 5 pi thirds. Okay. All right, there's one last equation I want to show you, and this is like a one-time thing. The reason I'm showing it to you is because it's not hard. There's a little trick to it, but I've seen this problem multiple times. So we're going to do sine x minus cos x equals 0. This is not a factoring problem. You can't factor this, okay? This is kind of like saying x minus y equals 0. There's no GCF. It's not difference of squares. You cannot factor this, okay? So what I'm going to do is I'm going to add the cos to the other side. Sine x equals cos x. What this means is I need to look at the unit circle, and sine represents my y coordinates, cos represents my x coordinates. I need to look at the unit circle and see where the y coordinate is exactly the same as the x coordinate. Pi fourths and 5 pi fourths. Okay. What I've noticed is it seems to show up once in every textbook. It's like every textbook I've ever looked at when I've taught this class, they always have this one problem. There's not another variation of it, this is it, okay? So, because you can't really ask that in any other way. There's like no other point on the unit circle that has that. They could say sine x plus cos x, and then they could say where is the y coordinate equal to the negative version of the x coordinate. That could be like another way they could ask the question, but this is not a factoring question, okay? So now that we've done it, I don't know, it might show up as like a bonus question somewhere. You don't have to memorize it, you just have to be able to think about it. Okay, does that make sense when we think about it? Okay, so I'm going to go ahead and give you a worksheet. So what should I do with number 1? You can add 1. So you don't have to treat this first one like a factoring problem. You can just solve for x, that's fine. So what do we do next? Divide by 2. So sine squared x equals 1/2. And how do we make it sine x and not sine squared? We square root both sides. So the squared and the square root cancel out. We get sine x. What is supposed to go in the front of a square root always? Plus or minus. And then do you guys remember how I handle the fraction? Yeah, I split the square root so it's on top and bottom. So I'm going to call this square root 1 on the top and square root 2 on the bottom. So now what I have is I've got sine, I should have had an x here, make sure you put an x there. Sine x equals plus or minus of 1 over square root 2. And are we going to find a number on the unit circle that looks like that? 1 over square root 2? No, because that's not proper, and our unit circle only has proper numbers on it. So we fix it by multiplying by square root 2 over square root 2. And so we have sine x equals the positive version and the negative version, and then what is the number? Square root 2 over 2. Okay. In the instructions, it says for the odd problems, find all solutions, and for the even problems, find the solutions from 0 to 2 pi. So I'm going to write on my paper so I don't forget that we're finding all solutions over here. So I'm going to be like, all solutions over on this side. This side is just from 0 to 2 pi. Okay? So we're just practicing both of those. So if we look at the unit circle, we are looking for y coordinates that are positive root 2 over 2 and y coordinates that are negative root 2 over 2. So we're going to have 4 answers. Okay, so what answers are you guys seeing? Pi fourths plus 2 pi k. Okay, what's another one? 3 pi fourths plus 2 pi k. 5 pi fourths plus 2 pi k. And 7 pi fourths. Okay, so that one's done.